Number 3, on the Unit 3 review, it says, it is known that 56% of all summonses issued by a particular precinct are for parking violations. If this department in January issues 700 tickets, what is the probability that at least 400 of them will be for parking violations? So P, our probability of success here, meaning they get a ticket for parking violations. Parking violations is 56%. We have a sample of 700 tickets, and then we also are looking for the probability that at least, so greater than or equal to 400 of them are for parking violations. So in this problem, we have to use the normal curve, but before we can even get to the normal curve, we have to calculate our mean, because we need to know where am I putting the number 400. So we calculate our mean again from the equation n times p. N is 700, P is 56%. And we get 392. So I'm going to put that in the center of my curve. So now for this 400, I know that I'm shading to the left, and I know that 400 is to the right. Sorry, I'm shading to the right because it's greater than. But we're also going to need to calculate a z-score. And in order to calculate a z-score, we have to use the formula, the square root of n times p times q. Q is going to be 0.44. Remember, p plus q, our probability of success plus our probability of failure, has to add up to be 1. So in this case, our p is 0.56, so q is 1 minus 0.56. Okay, so our standard deviation, again, is the square root of 700 times 56% times 44%, and we get 13.133-ish. So now, we have to change 400 to a z-score. But before we can actually change it, one thing that we're going to do is use something called the correction of continuity. Because we calculated the mean and the standard deviation, we need to make up for room for error. So we're going to change 400 by 0.5. Here's how we choose, do I add 0.5 or do I subtract 0.5? We look at our inequality. Greater than or equal to means that we need to shade not only to the right, but we need to include the number 400. So if we change it to 400.5, notice I'm not shading over the number 400. We want to shade over that number, so I'm going to drop back to 399.5. So my x is 399.5. My mean, we calculated, is 392, and our standard deviation is 13.133. So for our standard score, we're going to get to 2 decimal places, 0.57. Okay, and then now we're ready to find our actual probability. Our probability then of greater than or equal to 400, or at least 400, will come from our normal CDF, and then we're going to do 0.57 up to 10. So again, there's a lot of work involved for a question like this. So since there's a lot of work, this particular question is worth quite a bit on the test. Okay, so on the test, you are going to get a point for calculating the correct mean, the correct standard deviation, having your picture correct, changing x by 0.5 correctly, calculating the correct z-score, and then calculating the area correctly. You absolutely 100% have to show all of this work to even gain any partial credit. Okay, the next one. In a certain doctor's office, the waiting time is normally distributed with a mean of 40 minutes. So we're already given the mean, which means in the end, we're not changing x by 0.5. Whatever x is, it's staying the same because I was given my mean. I did not have to calculate it. And we're also given our standard deviation here of 8.8. Laura walks into the doctor's office. Find the probability that she will have to wait at least 60 minutes. So at least is greater than or equal to, but again, I'm going to keep it 60. I don't have to change it because I was given my mean and given my standard deviation. So now I'm just going to change 60 into a standard score. And we get 2.27. So then our probability of waiting at least 60 minutes is going to come from normal CDF, 2.27 to 10. And we end up with 0.0116037.563. Again, we want to round our area to 4 decimal places, 0.0116. Number 5, in a normal distribution, find the z-score that cuts off the middle 84%. So there are actually 2 z-scores that are going to cut off that middle 84%. Now because it's the middle, I know that these tails are equal in size. The entire curve is 100%. I'm going to take away the middle 84, but then I cut that in half. Okay, we're going to cut that in half because we know that the 2 tails are equivalent in size because the curve is symmetric. Now I have the area at the bottom of the curve. So z, remember, inverse norm, when we have area in the curve, we can use it to find that z-score. Inverse norm reads the bottom portion of the curve. So now we're going to do the inverse norm of 8%. And you get negative 1.405071561, which we want to round to 2 decimal places. However, we have both the negative and the positive. The curve is symmetric, so the bottom 8% has the same z-score as the top 8%. So our final answer, we could just say both plus and minus negative 1.41. Okay, number 6. It is claimed that 27% of all full-time employees of the SOT Corporation earn at least $50,000 annually. It says, what is the probability that a survey of 300, so this looks like an N here, will contain at least 75 employees that earn at least $50,000 annually. So at least $50,000 annually, I'm not using that number, that's used for the probability. This would be P, our probability of success. So this question is just like number 3. I'm given a probability of success, I'm given a sample size, and then I'm looking for a probability. I'm going to need to calculate the mean and the standard deviation. Because we're going to calculate the mean and the standard deviation, when I calculate my z-score, we're going to have to end up changing this 75 by 0.5. Okay, now we need to calculate our standard deviation. Our sample size is 300. P is 0.7. Remember to find Q. P plus Q equals 1. So if my P is 0.27, Q here is going to be 73%. So when we calculate, we're taking the square root of 300 times 0.27 times 0.73. We get a standard deviation of 7.6896. Now you could round this to 7.690. That's fine. I'm going to keep it 4 decimal places. Okay, so now we have to change 75 to a z-score. But again, we calculated the mean and the standard deviation. So we're going to change 75 by 0.5. This is greater than or equal to, which means when we shade, we have to include the number 75. If we change this to 75.5 and shade to the right, we would not be including 75. We have to shade over it to include it. So we're going to drop back, and we're going to change this to 74.5. So x is 74.5, our mean was 81, Our standard deviation, 7.6896. So when we calculate our z-score, we're going to end up with negative 0.845297547, which is about negative 0.85. Remember, we want to round our z-scores to 2 decimal places. Now to find our probability or area under the curve, we're going to use normal CDF. So we're going to do normal CDF, negative 0.85 to 10. And we get 0.80233758082. So to 4 decimal places, it's 0.8023.